Okay, welcome back to this is our video number 3 in this series. And so far we've talked about adding to eliminate a variable, subtracting to eliminate a variable. But now if you notice, things are a little mixed up. So the very first step in elimination is we have to make sure that the equations are all lined up. But as you can see here, I have x equals 3y. So if I was to look here, x over x, perfect. And it looks like it's y over y, but the equals has to be over the equals. So this equation is not lined up. And we need to rework that and make that happen so that we can use elimination. So how could we do this? Well, I need to get them lined up, and it looks like this 3y is on the wrong side of the equal sign. So I need to move it over the equal sign. Now we know how to move equations, so I'm just going to rewrite this real quick. If I think about moving that over, x equals 3y plus 11. If I wanted to move it, I would, well, it's positive, I'm going to subtract it. What I do to one side, I do to the other. Now I want to write this in the right order. I want it to be x then y so I can line these up. So I'm going to write x minus 3y equals, we move this, equals 11. So xy equals constant. Okay, now it looks like I can put these back together. So I'm going to rewrite this. I'm going to say, well, that means x minus 3y equals 11, and 2x minus 3y equals 16. And now that they're all lined up, I can combine them. Now, how do I want to combine these? Same steps as before. Nothing else has changed. We just had to line them up first. So I look at my coefficients. X has a 1 and a 2. Well, that's not going to work. Y has a negative 3 and a negative 3. So they're the same, which means if I put them together, that would be same signs add and keep would be negative 6. So I can't just add them. I'm actually going to have to subtract them. And what I do, I have to do all the way across. So remember, we need to distribute that negative. It has to go to everybody. So my positive 2 is negative. My 3y that was negative is now positive. The 16 that was positive is now negative. I would go ahead, and now that I have them lined up, now I'm just going to add them, right? I distributed that, so this subtraction is now really addition. So x and negative 2x, that would combine to negative 1x, or negative x. Negative 3, positive 3, those cancel. That makes it 0. And 11 and negative 16, well, that combines to negative 5. Now we're just all solving for x. We have eliminated y. We're going to divide both sides by negative 1. X is going to equal positive 5. So I think that my solution is going to be 5 something, right? I got to find that y. I don't know it yet. I'm going to go back to my original equations and use one of those. So I'm going to say, well, x is 5, and I'm looking for y. So that means 5 equals 3y plus 11. So I subtract 11 from both sides. So negative 6 equals 3y. Divide both sides by 3, and it looks like negative 6 divided by 3 is negative 2, so negative 2 equals y. So my solution is 5, negative 2. Don't forget, as a mathematician, you can go check to make sure that that is correct by plugging 5, negative 2 into both equations. All right, again, equations must be lined up. And I look here and I have a y over y and equals over, no, this isn't lined up at all. So we need to think, what can we do to get these problems to line up properly? And if you're thinking, well, there might be more than one way. True, there might be more than one way. But what I think I'm going to do is I'm going to turn, this looks like standard form in my second equation. So I'm going to turn the top equation into standard form by moving the x over. So I'm going to rewrite that and make sure I get it right. So 4y equals 2x minus 8. If I want to move the x over, this is a positive 2x, so I'm going to need to subtract it. And what I do to one side, I do to the other. I'm going to rewrite this x first because it's standard. So negative 2x plus, that's a positive 4y, so plus 4y equals 2x subtract 2x. Well, that cancels. And that constant is still that negative 8. Now that they're both in standard form, I can put these together. So I'm going to go ahead and just rewrite this. Negative 2x plus 4y equals negative 8, because this equation is equivalent to this one. And then I'm just going to rewrite the second one, line them up. 5x minus 4y equals 20. My question here would be, do I have like coefficients? Do I have common coefficients? X coefficients are negative 2 and 5. No. But then I have my y coefficients. I have a positive 4 and a negative 4. If I combine those, if I add them up, will that equal 0? Yeah, in this case it would. 4 and negative 4, when you put them together, make 0, right? So I'm just going to add. So I don't need to change any signs. I don't need to distribute. I just need to think straight up and down, vertically, put them together. So negative 2 and positive 5, well, that's 3x. 4 and negative 4, those cancel to 0, equals negative 8 and 20. Well, that would be 12. Now I'm going to divide both sides by 3. And then x would equal 4. So now I know half of it. I just got to go find the other set. Doesn't matter which one you use. I usually just use the top one or the one that looks the easiest. So 4y equals 2 times 4 minus 8. So 4y equals 8 minus 8, or 4y equals 0. We divide both sides by 4, and it looks like y is going to equal 0. That is my solution. 4, 0. Make sure the x comes before the y. Plug it back in and make sure you are correct before you move on. All right. 2x plus y equals negative 10, and negative y equals 2x plus 10. Again, they're not lined up. We cannot use elimination until we line these equations up and we make them look the way we want them to look. Now, we could turn the second one into standard form, or we could rearrange the top one. It's completely up to you. So pause the video, rearrange them and line them up, and I'm going to rearrange them both ways. Remember, as mathematicians, when we move problems around, it's up to us. We are in charge of those problems. So as you can see here in the first one, my first set, I rearranged the bottom to match the top. I said, okay, this is standard form. I'm going to put the bottom equation into standard form. And I did so by subtracting the 2x in front. Or, as mathematicians, I'm like, you know what? This is in slope-intercept. Can I turn the top equation into slope-intercept form? Yeah, you can. It does not matter. Both will give us the same result. So let's just do that real quick. I have 2x minus 2x. Okay, those are going to cancel if I just add them together, right? So I can just add these. Perfect. If I add those, 2x minus 2x cancels. I look at my y's. Y minus y. Well, y minus y also cancels, but I can't leave this empty. Something has to show up on an equation to keep that equal sign okay. I have to stay in balance. So I'm going to go ahead and write 0. Negative 10 equals 10, or negative 10 plus 10. It's negative 10 plus 10. Additive inverse, yeah, that's 0. And I look at it, I'm like, okay, I get 0 equals 0. That looks like, wait a second, 0 does equal 0. So according to this, I have infinite solutions. That is a true statement. Well, let's say you were working the second way. You turn them both into slope-intercept. And you look here, and the very first thing you see is y is over negative y. If I add a 1 and a negative 1, well, that's going to give me 0 as well, right? Those are going to cancel and eliminate, so I'm going to try that. I'm just going to add those up. Negative 1, well, 0, remember, has to have something, equals. And we're just adding negative 2x, positive 2x, well, that's 0. Negative 10 plus 10, well, that would be 0. So 0 would still equal 0. 0 does equal 0. This is an infinite solution. It's a true statement. So think about those, take your time with those, and remember, we can rearrange equations however we want to. We are mathematicians. You just have to follow the rules of what I do to one side, I must do to the other, and make them work in your favor. I'm going to pull up one more question here. These are the ones that sometimes trip us up because we have y equals, and honestly, the easiest way to solve this might be just graphing it, right? They're both in y equals mx plus b, and that's pretty pretty. And remember, we could have used substitution. We could have said, well, we can just put 3x plus 4 equals x minus 2. Absolutely. You're mathematicians. You're going to have those options to make decisions. But I want to show you it does work by elimination as well. So I'm going to put these together. I notice here my y's both have a 1, and my x's are different. So I'm just going to figure out how can I make these 1's disappear. Well, I can do so using subtraction. But to do so, I also want to make sure I remember subtraction means I need to distribute This becomes negative, this becomes negative, this becomes positive, because I'm going to change that so I can add them up. 1 and negative 1, when I put them together, 0, equals 3x minus 1x, 2x. 4 plus 2, 6. Just keep simplifying your way across, and then you start moving. 0 minus 6, negative 6, equals, we're going to go ahead and drop that 2x. 6 minus 6, that's what we asked to leave. Then we can divide both sides by 2. Negative 3 equals x. Now we can plug that back in to find our y. Either equation works just fine. 3 times negative 3 plus 4, so it looks like y is going to equal negative 9 plus 4, or y is going to equal negative 5. So my solution here is negative 3, negative 5. I would plug that back in to make sure it is correct, because it has to make both of those equations true in order for this to be the solution. Remember, it's where they intersect, it's where they overlap. So this point has to work in both.